Hello everyone, my name is Ali-Ayman. I'm an electrical and electronics engineering student at the University of Edinburgh. Welcome back. This is the fourth video on the series on algebraic methods. Today we'll be looking at negative and fractional indices. So, especially in basic math questions or math expressions, a raised to the power n, where a is a real number and n is a positive integer. We always see n, or not always, but especially in the easier math questions, we always see n being a positive integer. And what I mean by that is n is greater than zero, and n is a whole number. But what if n is not a whole number and n is less than, or n is less than zero? And lastly, what if n is equal to zero? And these different cases are illustrated here. So when we've got a raised to the power 1 over m, where m is an integer, we can rewrite this as the root m of a. So let me give you an example to make it more clear. So if m was 3, this would be the cube root of a. If m was 2, this would be the square root of a, and so on. Now, with the second case, we've got a raised to the power n over m. And the way we can rewrite this is the root m of a, and then all of this would be raised to the power n. So again, it's like before, but since 1 is not there and we've got an actual other integer here, n is an integer by the way, we have to write the expression like this. We have to raise everything to the power n. When a is raised to a negative number m, whenever any number is raised to a negative power, we have to flip the number. We have to make it a fraction, or if it's already a fraction, we flip it again. So in this case, we've got a raised to the power negative m. So we can rewrite this as 1 over a raised to the power m. And then any number raised to the power 0 is always 1. It should be noted that 1 over m and n over m are rational, i.e. they are in the form a over b, and this a over b and this form cannot be simplified any further. That's a very important thing to keep in mind. So now let's look at some examples. Look at this first set of examples. So for part A, we've got x raised to the power 3 all divided by x raised to the power negative 3. This is the same as writing x raised to the power 3 divided by x raised to the power negative 3. But here we've got a negative power. So we can rewrite this again as x raised to the power 3 divided by 1 over x raised to the power 3. And using the laws of division, or the laws of fractional division, what I like to call keep, change, flip, we can rewrite this as x raised to the power 3 multiplied by x raised to the power 3. And using the multiplication index law we looked at in a previous video, we will get x raised to the power 3 plus 3, which is x raised to the power 6. For part B, we can just use index laws as we did before. So x raised to the power 1/2 times x raised to the power 3/2 is the same as x raised to the power 1/2 plus 3/2, which is equal to x raised to the power 4 over 2, and that's just x squared. Now for part C, again, we can just use another index law this time. We've got x raised to the power 3, and all of this is raised to the power 2/3. So all we do is multiply the exponents here. So we do 3 times 2/3. So this is equal to x raised to the power 3 times 2/3. And that's equal to x squared. Okay, for part D, we've got 2x raised to the power 1.5 divided by 4x raised to the power minus 2.5. So I think the best way to tackle this question would be to rewrite it first as 2x raised to the power 3 over 2, and then divided by 4x raised to the power 1/4. And we can rewrite this again as x raised to the power 3 over 2 divided by 4 over x raised to the power 1 over 4. And then again, we can use the laws of division, and we will obtain 2x raised to the power 3 over 2 times x raised to the power 1 over 4, all divided by 4. Now, 2 divided by 4, because here we're multiplying 2 and 1 over 4, there's 1 there, so we're doing 2 multiplied by 1 over 4. The answer to that is 1/2 times, and then we have x raised to the power 3 over 2 times x raised to the power 1 over 4. So we can just use index laws. So we'll get x raised to the power 3 over 2, and we can rewrite this as half x raised to the power 3 over 2 plus 1 over 4, which is equal to half x raised to the power 7 over 2. Okay, and now for part E, we've got the cube root of 125x raised to the power 6. So I think it would be useful to rewrite this as 125x raised to the power 6, all raised to the power 1/3. And now we can use one of the index laws we looked at in the previous video and rewrite this as 125 raised to the power 1/3 times x raised to the power 6, all raised to the power 1/3. And this is equal to the cube root of 125 times x, and again we use the other index law, this time the power outside the brackets, and then we multiply the exponent, so this will become x raised to the power 6 times 1/3. The cube root of 125 is simply 5. So we get 5 times x, and then 6 times 1/3 is 2. So the final answer is 5x squared. Okay, and now for part F, we've got 2x squared minus x, all divided by x raised to the power 5. Now, I would find it useful to rewrite this as we did in the previous video, because each term in the numerator is divided by the denominator. So we can rewrite this as 2x squared over x raised to the power 5 minus x, all divided by x raised to the power 5. Now we can rewrite this as 2x squared divided by x raised to the power 5, because a fraction implies division, minus x divided by x raised to the power 5. Now let's start off with this first expression here. So we've got 2x squared divided by x raised to the power 5. Again, we can just use the index laws we looked at in the previous video, the the division index law, where we have to subtract the exponents. So this becomes 2x raised to the power 2 minus 5. And then minus, and then here we've got x raised to the power 1 divided by x raised to the power 5. So we use the division index law, and we get x raised to the power 1 minus 5. And this equals 2x raised to the power minus 3 minus x raised to the power minus 4. And we can obviously rewrite this using the laws of indices we looked at above, and we obtain 2 over x cubed minus 1 over x raised to the power 4. Now, for the second set of examples, we've got 9 raised to the power 1 over 2, and using the laws of indices we covered above, we can rewrite this as the square root of 9, and the square root of 9 is 3. Now for part B, we've got 64 raised to the power 1 over 3, and again, using the laws of indices we covered above, this can be rewritten as the cube root of 64, which is just 4. Now for part C, we've got 49 raised to the power 3 over 2. We can now rewrite this using a different law of indices. So we can rewrite this as the square root of 49, all raised to the power 3. Square root of 49 is 7, so this simplifies to 7 raised to the power 3. And 7 raised to the power 3 is 343. Okay, now for part D, we've got 25 raised to the power minus 3 over 2. So using two laws of indices, we can rewrite this as 1 over 25, all raised to the power 3 over 2. And then this simplifies to square root of 1 over 25, all raised to the power 3. Square rooting the numerator and the denominator gives us 1 over 5, all raised to the power 3, and then cubing the numerator and the denominator gives us 1 over 125. In this third example, we're given an expression y equals 1 over 16 times x squared, and it wants us to express both of these in the form k times x to the power n, where k and n are constants. So part A wants us to find y raised to the power 1/2. So y raised to the power 1/2 is equal to 1 over 16 times x squared, all raised to the power 1/2. And again, using one of the index laws we looked at earlier, we get 1 over 16 all raised to the power 1/2 times x squared all raised to the power 1/2, because we raise all the contents inside the bracket to the power 1/2, obviously if they're multiplying. So 1 over 16 raised to the power 1/2 can be rewritten as the square root of 1 over 16, and then x squared all raised to the power 1/2 using the bracket, the multiplying exponents outside the brackets. Using that index law, we get x raised to the power 2 times 1/2, and then this simplifies to 1 over 4, because the square root of 1 is 1, the square root of 16 is 4, times, and then 2 times 1/2 is 1, so we get 1/4 times x to the power 1, which is equal to 1/4 times x. Now for part B. This time we have two operations we have to conduct on this expression y. We have to inverse y, and then we have to multiply it by 4. So let's start off by inversing y. So for the sake of simplicity, I'm going to rewrite 1 over 16 x squared as x squared over 16. And then y raised to the power negative 1 is equal to the reciprocal of this. So we flip this fraction, again using the laws of indices we looked at above. That gives us 16 over x squared, and then 4y times, and then 4y raised to the power negative 1 equals 4 times 16 over x squared, and 4 times 16 over x squared is equal to 64 over x squared. And using the laws of indices we looked at before, this can also be rewritten as 64 times x raised to the power negative 2. Now here's the first of two exam style questions we'll be looking at. I'd like you to pause the video and attempt this question. And then once you're done, you can resume the video and compare your answer to the one I will present shortly. Okay, so I'll show you how I would deal with this in an exam style situation as I've done before. So 81 raised to the power 1/4 is equal to the fourth root of 81 is equal to 3. Now for part B, we have to simplify x times 2x all raised to the power -1/3, and then all of that is raised to the power 4. So what I would do is I would deal with this expression surrounded by the brackets first. So I'd deal with 2x raised to the power 1/3 first, and that gives us 2/x raised to the power 1/3. And now we can deal with this for this fourth power there. So we can raise everything here to the power 4. So 2 times x raised to the power -1/3, all raised to the power 4 is equal to 2/x raised to the power 1/3, all raised to the power 4. And we basically raise the numerator and the denominator to the power 4, and this gives us 2 raised to the power 4, all divided by x raised to the power 1/3, all raised to the power 4. 2 raised to the power 4 is equal to 16. And then we simplify this expression using one of the index laws, and we get x raised to the power 1/3 times 4. And this gives us 16 over x raised to the power 4/3. But we're not done yet because we have this x here. So we have to multiply this expression by x. So x times 16 all divided by 4, all divided by x raised to the power 4/3 is equal to 16x divided by x raised to the power 4/3. I find it easiest to just use index laws here. So we can just, and then 16 divided by 1 is just 16. So this simplifies to 16x raised to the power 1 minus 4/3, since we're using the division index law. And that all simplifies to 16x all raised to the power -1/3, and we can rewrite this as 16 over x raised to the power 1/3, and 16 raised to the power 1/3 is just equal to the cube root of x, so we can rewrite this as 16 divided by the cube root of x. Again, I'm just using, so throughout all these examples we've been doing, I'm just using, a mix of all of the laws of indices, sometimes interchangeably, sometimes using one. Please do make an effort to realize whenever I mention the fact that I'm using a particular law of indices, make sure you know which one exactly it is from the examples I've given above, so that the whole picture is clear. And now we've got the last set of exam style questions. This is very similar to one of the examples we looked at before. So this is a very good opportunity to test what you may be able to recall from that particular example. So pause the video and attempt this question, and then when you're done, resume and compare your answer with mine. Okay, so let me show you how I would tackle this, again, in an exam style environment. So we've got y equals 1/8 times x cubed, and then y raised to the power 1/3 is equal to 1/8 times x cubed all raised to the power 1/3. and that simplifies to 1/8 all raised to the power 1/3 times x cubed all raised to the power 1/3. And then this can be rewritten using the laws of indices as the cube root of 1/8 times x raised to the power 3 times 1/3. And that equals to 1/2 times x raised to the power 1, or just half x. For part B, we have to find half times y raised to the power -2. So I would prefer just starting off with finding y raised to the power -2 first, then dealing with the half. So y raised to the power -2 is equal to 1/8 x cubed all raised to the power -2. And so that you see what I'm trying to do, I'm going to rewrite this as x cubed all raised to the power 8, and then x cubed divided by 8 all raised to the power -2. This negative sign here means we have to flip this fraction, so we end up with 8 over x raised to the power 3 all raised to the power 2. 8 squared is 64, and then x cubed raised to the power 2 is equal to x cubed times 2, which is equal to 64 over x raised to the power 6. And we can obviously rewrite this as 64 times x raised to the power -6. But we've missed out, we still haven't dealt with the half, so half times y raised to the power -2 is equal to half times 64 times x raised to the power -6, which is equal to 32 x raised to the power -6. And that's the final answer. So feel free to compare your answers with what I got here. And this is the end of the video. If you'd like to further develop your skills, and become better at, maths, physics, chemistry, economics, stick around on this channel, like, subscribe. There'll be more videos coming out on a variety of different topics, and hopefully you can use this content to help develop your studies, yourself, and hopefully the effect will be net positive. So yeah, this is the end of the video. We covered in this video negative and fractional indices. Again, memorize these rules. These rules are very, very important. They will come up in many different exam style questions. I'll be posting exam style questions for this topic and hopefully for all the previous topics. And stay tuned for more videos. Again, if you enjoyed it and you want to see more of this, please subscribe, and I'll see you soon again. Bye.